Hi, how are you doing? In a previous video, we learned how to differentiate a given function using parametric equation. In this video, I want us to try one more example, but in addition to that, we are also going to remind ourselves how to differentiate using two more methods. So this will be a combination of several methods. If you have not checked my other videos, you can check them on the link shown here or in my video description here. It is preferable you watch my videos from the first lesson to the last if you want to easily grasp the concepts. But if you already have the basic concepts, you can go directly to a certain method that you want to learn. Also remember to share the videos with other students, like the video and leave your question in terms of a comment. Now we should not get to the task. This is electrical engineering past paper. This is diploma June July. Diploma in electrical engineering and electrical engineering. This is June July 2016. June July 2016. So we are told question 6. We are going to answer question 6A and B. We are told find dy dx given that number 1 is y is equal to x cubed cosine cubed cos cubed 2x. So in this case, you are not told which method you are supposed to apply or you are supposed to use. It's up to you from your own experience. Whenever you see a question, you realize this is supposed to be done using this method. So it's important to keep on practicing so that you can gain enough experience in various methods of differentiation. Actually, so far in my videos, we have covered 5. So you can check the videos. Now, here you should notice this is a product of two differentiable functions, x cubed and cos cubed 2x. You should also notice to differentiate cos cubed 2x, you need to use chain rule. What is the same as saying y is equal to x cubed, that is the first differentiable function, times cos 2x power 3 times cos 2x power 3. So if we let this to be our u and this one to be our v, derivative of y with respect to x will be equal to u dv dx plus v du dx. Because we had already learned how to use product rule in previous videos, I'll not dwell in all the steps. I'll now skip some of the steps. So if you have not checked my previous videos, it's important to check them so that we don't get confused along the way. Now what is our u? Our u is x cubed. Let us differentiate it. Derivative of u with respect to x. This is 3x squared. You needed somewhere later, so let us just leave it like that. So that now v is equal to cosine of 2x power 3. So that now we say that maybe a variable a to be equal to 2x, and therefore v is cos 8 power 3. And also if we say cos t to be cos a, we'll have v is equal to t cubed. V is equal to t cubed. So the innermost function is this one, a is equal to 2x. The next function is this one, t is equal to x cos a, and the third function is this one, v is equal to t cubed. So that now dv dx, we are going to differentiate the outermost, the cube, is derivative of v with respect to t. First, t is equal to 3t squared, t is dependent. Next, we are going to differentiate t with respect to a, dt, dA, and finally we are going to differentiate a with respect to x, dA, dx. So now you can see if you cancel dt, dt, dA, dA, you get dv dx. Now what is dv dt? We differentiate this one, we get 3 t squared dt dA. We differentiate this one, we get negative, maybe this for multiplication, negative sin a, negative sin a. If you differentiate this, I use a dot for multiplication, we get 2. dA dx is equal to 2. So now let us rearrange. Here you have 6. Now we have a negative 6 t squared sin a. But what is t? T is equal to cos a. Negative 6 cos squared a sin a. But what is equal to a? Negative 6 cos squared 2x sin 2x. So that is our dv dx. dv dx we needed in our formula. So that dy dx is equal to now u, which is x cubed, times dv dx. dv dx we have just found it, this one, negative 6 cos squared 2x sin 2x plus v, which is equal to cos cubed 2x times du dx, which is 3x squared times 3x squared times 3x squared. So this one will be equal to what are the common factors? This cube is multiplying here. This one has a square. Here you have 3, here you have 6. So we can factor out. Here you have a cos squared, here you have a cos cubed. So which are the common factors? There are 3. Suppose you have a 6 and a 3. X squared. Suppose you have an x cubed and an x squared. And cos squared. 2x. If you do that, you will be left with negative 2 here, and x. The whole of this will be outside, and sin 2x. I wish you could have started with the positive. I prefer that, but there is no problem. Plus, here we have factored as a square, so we are left with cos 2x only. Because 3x squared is outside the bracket. Cos 2x. Cos 3x squared, this one, is already outside the bracket here. So that is it. That's how you should approach that one. You can say that one required you to apply the knowledge of differentiation by using product rule and chain rule. My space is limited, so sometimes I might block you because I have a limited space. But all you need is to pause or replay the video. Now number 2 of the same question, we are supposed to differentiate this. This one, you should notice, here you should apply differentiation of implicit functions. We have already done a video on how to differentiate implicit functions. The key to this method of differentiation is practice. So that the moment you see a question, you can quickly notice the method, you can quickly identify the method of differentiation you are supposed to use. Now, we are going to go ahead and differentiate this, so that this will be d derivative with respect to x xy cubed plus y cubed x cubed plus 4 is equal to 0. So we do the differentiation. This one, notice you use product rule here in this case and this case. And remember, you have said the formula for product rule. If you are to differentiate maybe w, if you are to given w is u v, I'm avoiding using y because we already have y here. W prime is u v prime plus v u prime. I think this is a formula we have stated so many times. This is u prime. So in this case, we take our u, which is x, differentiate v through b3 to b3y squared, normal differentiation under dy dx, plus v, what is our v? Y cubed. Differentiate our u, differentiate u, differentiate x with respect to x, you get 1, so that is done. Plus take this one, what is our u in this case? Take the first one to be our u, it is y cubed. Differentiate x cubed with respect to x, that will be 3x squared, 3x squared, so that you have evaluated u v prime plus, you are using product rule, so you need to get the next one. It is v, what is our v? X cubed is x cubed is our v. Differentiate our u. If we differentiate y cubed, it will be 3y squared dy dx. 3y squared dy dx. So we are done with this one. Now, if we differentiate the constant 4, you get 0. If you differentiate the constant form, you get 0. So, and now we are done. So we just equate with 0. Factor out the term with dy dx. So dy dx. Each term of dy dx. 3xy squared. This one 3xy squared plus this one 3x cubed y squared 3x cubed y squared dy dx. Okay, we are factoring out dy dx. We also have plus this one y squared y cubed plus 3, okay, plus this one 3 y cubed x squared is equal to 0. Or we can take this to the other side of the equation. Dy dx 3x y squared plus 3x squared x cubed y squared is equal to negative into bracket y cubed plus 3y cubed x squared. So you just divide dy dx dy dx is equal to negative y cubed plus 3y cubed x squared all over 3 x y squared 3xy squared plus 3x cubed y squared. So that's how you go about that one, using implicit differentiation of implicit functions. Though it could have been possible, y cubed, to factor out y cubed, take 4 to the other side, divide, then take cube root, then use both chain and quotient rule to do that. I think it is much easier if you have to use implicit equations. For number 3, I'll skip it for a while. I have realized there's something I needed to check from the S&P table, so it will call me to stop the video. So instead of doing number 3, I'll go to the same question B. So that later I've realized the other one has an identity that I needed to check from the S&P table, so I'll skip that for a while. I'll do that question later. Now, if we are told if y is equal to 8x squared exponential negative x, show that d squared y dx squared plus 2 dy dx plus y is equal to 16 exponential negative x. You have y is equal to 8x squared exponential negative x. So notice the method of differentiation we should use is product rule, so that dy dx is u v prime plus vu prime. Our u is 8x squared, our derivative of u with respect to x 16x, our v is equal to exponential negative x, our dv dx is equal to negative exponential negative x. I think this one we have already done in previous method, so it takes less time. Then so that we say dy dx is equal to u 8x squared dv dx, which is negative. We should have put space here, negative, because of this negative exponential negative x, plus, which is exponential negative x times du dx. Du dx is 16x. So we should have started with 16x to make it look nicer. 16x is 16x exponential negative x. We can factor out exponential negative x if you want, but it's not a must. I would rather we don't factor out. So to get the second order derivatives of y with respect to x, this will be the derivative with respect to x of the first order derivative. That now this one become d dx. Yeah, you could factor out if you want, but it's not a must. Negative 8 squared x squared negative exponential negative x plus 16x exponential negative x, like that. Notice here we have to use product, and here you have to use product rule. In both cases you have to use product rule. So I'll not keep on restating the formula, so that now the second order derivative of y with respect to x, this one, which is the derivative of the first, which is the derivative with respect to x of the first order derivative. So this is the first order, we are differentiating it again with respect to x. I'll just go ahead, use the formula without restating it, because we have already stated here. Here you have a u, negative 8x squared, negative. We have a v, we need to differentiate v now, which is, if we differentiate v to produce a negative, so it will be negative exponential negative x. So we have taken care of u, v prime, plus v exponential negative x. We differentiate u. u is negative 8x, so it will be negative times negative 16, because it's 2 times negative 8, negative 16 x. Notice here we have a negative, this one. We have a negative, this one. And we are also multiplying this and this, so let me write in a way you be able to see. So it will be negative 8x squared times negative 8x squared times negative exponential negative x. I'm done with this. Out of this one, I'm done. I'm now here plus. I'll use product again. I'll take u, which is 16x, differentiate v prime. It will be a negative when you are differentiating this one, exponential negative x, plus v. What is our v in this case? Plus exponential negative x, this v, differentiate u prime is 16 times 16. So that is it. You can look for common factors, or do you have any? Anyway, I don't know. Let's write it in a proper way. So we have negative and negative is a positive. 8x squared exponential negative x, this one, minus, I'll take this negative, 16x exponential negative x. I've started with negative 16x exponential negative x, plus, see this negative, this one, negative, this, so this one will be negative 16x. I think we could have combined those two, exponential negative x, and then plus finally 16 exponential negative x. You could have combined this and this, but there's no problem. Okay, maybe let us do it. 8x squared exponential negative x. This and this are similar, minus 32 x exponential negative x plus 16 exponential negative x. So now we are supposed to add that second order twice first order, but y itself should reduce to this. So let us prove this equation. This equation, I'll take this 8 x squared exponential negative x minus 32 x exponential negative x plus 16 exponential negative x. I'll take the first order. This one, I'll multiply it with 2 plus twice of this negative 8 x squared exponential negative x plus 16x exponential negative x, that, then I'll add y to see whether it will equate to this one. Where is our y? This is our y. 8x squared exponential negative x. That is our y. So this is 8x squared exponential negative x minus 32 x exponential negative x plus 16 exponential negative x, we are here, minus, open the bracket, negative 16 x squared exponential negative x. So you multiply this one and this one. If you multiply now this one and this one, it will be 32 plus 32 x exponential negative x. And then finally plus this plus 8 x squared exponential negative x. If you look at this one, here you have 8 terms. Here you have 16. So that one together with this one will cancel out this one. Here you have negative 32, positive 32. So this one will cancel out that one. So we are only left with 16 exponential negative x. And you are told that equation should balance with this 16 exponential negative x. So you have proved this, the whole of this has reduced to 16 exponential negative x, which have equated with the other side. 16 exponential negative x. So we have proved that that is true. So this is using higher order derivative. I had said I would do something on higher order derivative, how to differentiate twice or thrice. So I think how here we have already learned how to differentiate twice or thrice. When you are differentiating for the second one, we call this one a second order derivative, a first order derivative. This is the original function itself. So to get a second order derivative, here, to get a second order derivative, you need to differentiate that first order derivative with respect to that variable. If you follow these videos consistently, you will be very good in calculus. Calculus is one of the most key areas. So that is it. Meet you in the next one, where we'll be discussing application of differentiation. That is the turning point or critical points, and also tangent and normal to curves.